So we now know the top three series for the course. You gotta know them. E to the x, radius of convergence infinity. 1 over 1 minus x, the geometric series, radius of convergence 1. And sine x, radius of convergence infinity. Here's an amazing fact. You could take derivatives and integrals of series term by term. So we can differentiate and integrate term by term to get more series. The amazing fact about this is this does not change the radius of convergence. This doesn't change R. What do I mean by differentiate and integrate term by term? Example. Cosine x. We know cosine x is the derivative of sine x. And we know sine x is this Taylor series. So that means I could differentiate the sum, n going from 0 to infinity, of minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Now when I say differentiate and integrate term by term, what I mean is you just take the derivative like you'd expect. You just differentiate x using the power rule. Derivatives of Taylor series are super nice. When you take the derivative, the only thing that gets affected is the power of x. So it's the sum n going from 0 to infinity. Everything else is the same. I still have this 1 over 2n plus 1 factorial. But then I'm going to differentiate this x, the power rule. 2n plus 1, x to the 2n. So I bring the exponent down in front and subtract 1. There. That's the Taylor series for cosine x. And the radius of convergence doesn't change. Now you might notice I have a 2n plus 1 here and a 2n plus 1 factorial. The last term in the factorial will cancel with this term. If you'd like, you could rewrite it as the sum going from 0 to infinity of minus 1 to the n, x to the 2n over 2n factorial. That'd be okay too. But still, I got the Taylor series for cosine x centered at 0 really easily. All I did was take the derivative of sine x. Now, if you remember the Taylor series for sine x, these are the odd powers, cosine, the even ones. So cosine has series 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, and so on. Okay, so we got the Taylor series for cosine x just by differentiation. Let's do another example. What if I write down this? Arctangent x. Arctangent x, now if you remember your calculus from last quarter, this is the integral from 0 to x of 1 over 1 plus t squared dt. This was a fact we saw earlier in our calculus experience. Now, in the previous video, we used the geometric series to find the series for 1 over 1 plus t squared. So if you go back to that video or you recalculate, you you get the sum, n going from 0 to infinity, minus 1 to the n, t to the 2n power. So we got that by manipulating the geometric series. Now, when you integrate with respect to t, you could just operate on the t. What I mean is, this is the integral from 0 to x, and then when you, well, it is, but when you integrate, you can integrate term by term. So I get the sum, n going from 0 to infinity, minus 1 to the n, and then I'm going to integrate the t to the 2n. So you get t to the 2n plus 1 power divided by 2n plus 1. And I'm going to evaluate that at t equals 0 and t equals x. Okay, well, I plug in x, so I get the sum going from 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1. Then I subtract, and I plug in 0 for t. But if you notice, plugging in 0 for t just gives me 0. I have 0 times everything. So there, I'm done. This is the series centered at 0 for arctangent. Now, if you like to see what these terms look like, you could plug in values for n. So if n equals 0, I get x to the first power over 1. If I plug in n equals 1, I get negative x cubed over 3 plus x to the 5th over 5 minus x to the 7 over 7. It's very similar to the series expansion for sine x, except we don't have the factorial. The difference is I'm not dividing by the factorial. Another difference is we use the series here to find the series for arctangent. We use the geometric series with radius of convergence 1 to find the series for arctangent. That means the radius of convergence for this series also 1. If you didn't believe that, you could always do the ratio or root test or something other convergence test. I'd use the ratio test to find the radius of convergence, but it's 1. Meaning arctangent is only equal to this series for values of x in between -1 and 1.